Hi everyone. Today we're going to be completing our notes on section 3.3, which is dividing polynomials. Today we're going to be discussing two different methods for dividing polynomials, those being synthetic division and long division. We'll start with synthetic division. We use synthetic division to divide polynomials if the divisor is of the form x minus c. This method is quicker than long division. So x minus c here, so far we've seen this in the form of a factor of a polynomial. So x minus c, if we have one factor of the polynomial, we can use one of these division methods to find the factorization or to find other factors of the polynomial. So it's a great way to divide out that factor, which then simplifies the problem for us. So taking a look at long division, as a reminder, the dividend is inside this division symbol. On the outside here is our divisor, and then our answer here on top, this is our quotient. So to start, we start with this first term here. Think of this as the first place value of a number. We ask ourselves, can we divide the binomial x minus 3 from x cubed, this first term? Well, no, we're trying to divide out a binomial from a monomial, just this first term. So then we have to consider the next term here, the 4x squared. So now we're dividing a binomial divided by a binomial, which we can do. So we have to ask ourselves, what quantity must we multiply x minus 3 by in order to divide it from the binomial x cubed plus 4x squared? And the answer to that is x squared. So I'm just looking at this first term here. We're really trying to cancel out that first term. So what quantity do I have to multiply x by to get to x cubed? The answer is x squared. So when we multiply x squared by this binomial x minus 3, we get x cubed minus 3x squared. Okay, depending on how you do long division, whether you add the quantity or you subtract the quantity, that's going to depend on your sign here. I'm going to say subtract, so we have x cubed minus 3x squared. Okay, so when we're subtracting these here, we get that the x cubed terms cancel out. We get 4x squared minus negative 3x squared, which gives us a positive 7x squared. Okay, we move on to the next term. So we add on the next term in the dividend, and we have to ask ourselves, what quantity do I have to multiply x by to get to 7x squared? The answer is 7x. So we multiplied x minus 3 by 7x. We get 7x squared minus 21x. And again, I'm going to subtract these two binomials. So the 7x squareds cancel. We have negative 5x minus 21x minus negative 21x, and we get positive 16x. And finally, what quantity do I have to multiply x by to get to 16x? The answer is 16. So we multiply x minus 3 by 16, and we get 16x minus 48. Okay, and when we subtract these, we have 5 minus negative 48, and we get 53. So we find that when we divide these out, we get the quadratic x squared plus 7x plus 16, and then we have the remainder plus 53 and then over x minus 3. So this last term here is not part of the, this is not a power term. This isn't part of the polynomial. This would be a rational term, okay? So this would be the remainder here. All right, so for the synthetic division, this formatting is a little bit off, but the divisor is going to be 3. So this would be the root here. So remember the factor x minus c, the root is 3. Okay, so that's going to be our divisor. The dividend is just the coefficients in descending order. So looking at this cubic here, the coefficients are 1, 4, negative 5, and 5. It's critical that these are in descending order. We're looking at the polynomial in standard form. If there are any terms missing, so I see we have our cubic, quadratic, linear, and constant terms here, but if any of those were missing, if we had like maybe a 0x for the linear term, we do have to include that coefficient as a 0 in our synthetic division. So when using synthetic division, we start by bringing down the 1, or that first coefficient down here, and then we're going to multiply 3 by 1, and whatever that product is going to be put to the next place here. And then we add straight down. So 4 plus 3 is 7. We multiply again. So 3 times 7 is 21, and then we add straight down, 16. Multiplied again, 48, and then we add straight down is 53. So this last quantity here is our remainder, okay? So what we have here is we can see our answer here. This 1 is in the quadratic place, so this would be x squared. The 7 is in the linear place, so this would be plus 7x, and then the 16 is in the constant space, so we have plus 16, And then finally, our remainder, 53 over our divisor, x minus 3. Okay, so let's get some practice. Synthetic division. Synthetic division is a quick method of dividing polynomials when the divisor is in the form x minus c. Let's try a few examples. So here we have, in the form x minus c, we have x minus 4. So that tells me that my divisor, my root, is 4, positive, and we're going to set up our synthetic division. Writing the coefficients in decreasing order, we get 6, we get negative 26, and positive 12. So first we start by bringing down our 6, and then we multiply 4 by 6. We get 24. We're going to write that up here, and then we add straight down. So negative 26 plus 24 is negative 2, and then we multiply by 4. So we get negative 8, and then we put that up here and add straight down. So we got 12 minus 8 is 4, and this is our remainder here. So this tells us that this is equal to 6x minus 2, and then plus 4 over our divisor, x minus 4. All right, we'll try another. So here we have our factor, or our root, x equals negative 3. And then we'll write our coefficients in decreasing order. So we have 5, negative 2, 1, and negative 10. So we start by bringing down 5. We multiply by negative 3. We get negative 15. Adding to negative 2, we get negative 17. Multiplying that by negative 3, we get positive 51. And then adding that to 1, we get 52. And then multiplying by negative 3, we get negative 156. So then our remainder is negative 166. Okay, so this is equal to 5x squared. This is the quadratic term, and then minus 17x, that's our linear term, and then plus 52, and then minus our remainder, 166 over x plus 3. So this brings us to our factor theorem. Our factor theorem states that if c is a zero of polynomial p, if and only if x minus c is a factor of the polynomial p. Okay, so this if and only if statement means it's a biconditional statement. It goes both ways. So c is a zero of p if x minus c is a factor, and then also if x minus c is a factor of p, then c is a zero of p. So it goes both ways. All right, let's get some practice. So given polynomial p of x is equal to x cubed minus 7x plus 6, show that p of 1 equals 0, and then use this fact to factor the polynomial completely. Okay, so we know that p of 1 equals 0, so that tells me that x minus 1 is a factor of p of x. Okay, so that tells me that if we were to use synthetic division, we would divide by that root of 1, and then writing out our coefficients here, we have 1 in the cubic spot. We don't have a quadratic term, so that coefficient is 0. We have a linear term of negative 7x, and then a constant of 6. So we'll start by bringing down 1. We get 1 times 1 is 1. Adding straight down, we get 1 again. 1 times 1 is 1. Adding straight down, we get negative 6. And then 1 times negative 6 is negative 6. And finally, adding straight down, we get 0. So remember, this last piece here is our remainder. So we have a remainder of 0. So by using synthetic division, because we have a remainder of 0, that tells us that this factor divides out the polynomial evenly. And so the factorization for p of x looks like x minus 1 times x squared plus x minus 6. Now we have to check and make sure that this can't be factored further. I noticed that the quadratic factor here can be factored into x plus 3 and x minus 2. And so this is the complete factorization of polynomial p of x. All right, let's try another. Given that f of 2 equals 0, factor f of x completely. Okay, so again, f of 2 equals 0 tells us that x minus 2 is a factor of f. So we're going to set up our synthetic division. So we have 2 as our divisor. So we have coefficients 2, negative 9, negative 2, and 24. So we start by bringing down 2. Multiplying 2 times 2, we get 4. Negative 9 plus 4 is negative 5. 2 times negative 5 is negative 10. And we have negative 2 minus 10 is negative 12. And then 2 times negative 12 is negative 24. Adding these up, we get a remainder of 0. So that tells me that this factors evenly, or this divides out evenly. So then the factorization for f of x is the quantity x minus 2 times the quantity 2x squared minus 5x minus 12. And let's see if we can factor that further. So we have x minus 2. I know that the leading coefficient is 2, which is prime. And so now we're looking for factors of 12, where the product of those factors, when multiplied by 2, adds up to negative 5. Those factors are 3 and 4. So that tells me that if we multiply 2 by negative 4 and x by positive 3, when we multiply, or when we add these up, we get negative 5. Okay? So this is the complete factorization of f of x. All right. Now let's use long division. We'll start with this first problem here. This is something that you might have seen earlier in grade school. We can go ahead and use long division here. So the dividend is 1,573. We're going to divide this by 13. So we start by looking at the thousands place. Can we divide 1,000, or really just 1 by 13? No, we can't. So we look at the next digit, 15. How many times does 13 go into 15? It goes in once. Subtracting 13, we get 2. Bring down the 7. How many times does 13 go into 27? 2 times. So we get 26 minus 1. Bring down the 3. How many times does 13 go into 13? The answer is 1. Subtract 13, and we have a remainder of 0. Okay? Let's practice with this next one. So we have x cubed plus 5x squared plus 7x plus 3, and we're dividing it by the quantity x plus 3. So we start with the x cubed term. Can we divide x cubed by the binomial x plus 3? No. We have to look to the next term with 5x squared. So what quantity would I have to multiply x by to get to x cubed? The answer is x squared. So when I multiply the binomial x plus 3 by x squared, we get x cubed plus 3x squared. I'm going to subtract this. Don't forget those parentheses. We're subtracting the whole quantity. And we get, let's see, 5 minus 3 would be 2x squared. Bring down the 7x. What quantity do I have to multiply x plus 3 by to get to 2x squared? The answer is 2x. So I'm going to multiply this by 2x, and we get 2x squared plus 6x, and we're going to subtract this whole quantity here. So we get x, and then we bring down the plus 3. So what do we have to multiply x plus 3 by to get x plus 3? The answer is 1. And so we subtract x plus 3, and we get a remainder of 0. So this tells me that this factors to, or at least this divides out to x squared plus 2x plus 1. So we get this right here. All right. Let's try a few examples here. So using long division, we have x cubed minus 2x squared plus 4x minus 1 divided by quadratic trinomial x squared plus 2x minus 1. All right. So we're dividing, we'll start with the x cubed. We're dividing a monomial by a trinomial. Can't do that. So now we look at the next term, a binomial divided by a trinomial. Can't do that. So then we look at the next term as well, a trinomial divided by a trinomial. Yes, we can do that. So what do we have to multiply x squared by to get to x cubed? The answer is x. So now we multiply our quadratic trinomial by x, and we get x cubed plus 2x squared minus x. We're going to subtract this from this grouping here, this polynomial. And what we get is negative 4x squared, and then we get plus 5x. And then I'll go ahead and bring down my minus 1. So what do we have to multiply x squared by to get to negative 4x? The answer is negative 4. So I'm going to multiply everything by negative 4. We get negative 4x, and then this would be minus 8x, and then plus 4. We're going to subtract this whole quantity here, and we get that these cancel. We get a positive 13x, and then we get a negative 5. Okay. So this is equal to x minus 4 plus 13x minus 5 all over x squared plus 2x minus 1. So this is our remainder. All right. Last one here. We have 2x to the fourth plus 5x to the third plus 7x squared plus 16x plus 15. And we're dividing this by the binomial 2x plus 3. All right, so we'll start with the first two terms because we can't divide that first term. So first two terms, what do I have to multiply 2x by to get 2x to the fourth? The answer is x cubed. So when I multiply this, we get 2x to the fourth plus 3x cubed. And we're going to subtract this. And we're left with 2x cubed. And then we bring down our 7x squared. Okay, what do I have to multiply 2x by to get to 2x cubed? The answer is x squared. And so now we can subtract. We get 2x cubed plus 3x squared. We're going to subtract that whole quantity. And we get 4x squared. We'll bring down our 16x. So we have to multiply the 2x to get to 4x squared. We multiply by 2x. And so then we get 4x squared plus 6x. We're going to subtract that. And we get 10x. We bring down our 15. What do we have to multiply 2x to get to 10x? The answer is 5. And so we get 10x and then plus 15. We're subtracting this. So look at that. We get a remainder of 0. So this divides out to a nice cubic polynomial here. All right. So these have been our notes on 3.3, synthetic and long division. We're going to get a lot of practice in class, so we'll see you tomorrow. Have a great day, everybody. Goodbye.